Good morning, guys. Well, it's morning for me. So today we're going to do lesson 0.3. We're going to review intercepts, symmetry, even and odd, and intersections. Okay. We want to remember that we're picking up different ways to find these things and what's going to be faster for you. Okay. So we're going to start out with x and y intercepts. The x-intercepts are the points where a graph crosses or touches the x-axis. The y-coordinate is 0. To find the x-intercept, let y be 0 and solve for x. So remember, it's a coordinate where we have a number, comma, 0. And for the y-intercepts, they're points that are graphs that crosses or touches the y-axis. So plug in 0 for x and then solve for y. So that coordinate would be 0, comma, number. Okay. And there doesn't always have to be an x-intercept or a y-intercept. But for it to be a function, it would only have one or none y-intercepts. They can't have two. Otherwise, it's not a function. With x-intercepts, it could be anything. Okay. So example 1, find the y and x intercepts for y squared minus 3 equals x. Now, there's different ways we could do this with graphing and all that other stuff, but the easy thing to do is do what it says up here, plug in. So let's solve for the x-intercept first, which means I'm going to plug in 0 for y. And we get that -3 equals x. So our x-intercept is -3, 0. Remember that an intercept is a coordinate pair, so you need a coordinate as your answer. Okay. The y-intercept, of course, we are going to plug in 0 for x, so we get y squared minus 3 equals 0. And then we're going to solve y squared equals 3. How do you get rid of a square? You take the square root, and remember there are two answers for a square root, so it's plus or minus the square root of 3. We need to write this as a coordinate pair, but we can write it all in one as 0, comma, plus or minus square root of 3. Now, because there's two y-intercepts, we also know that is not a function. And if you remember the other day, we see that y squared is a parabola that's on the side. Okay, just like down here. Okay, symmetry. You guys aren't. So, of course, symmetry to the y-axis reflects over the y-axis. X-axis symmetry reflects over the x-axis. Of course, this is not a function. And then we have the origin symmetry. Origin symmetry, they say reflects through the origin 0, 0. And it does, it reflects, right? If the mirror was right. No. So it's saying like just that point, like you're gonna reflect. Each point is right here. If I reflect across the origin, I get it right over here. But I like saying that it rotates. I think it's easier to say that it rotates 180 degrees around the origin. Okay, whatever way works for you works. Okay, graphs can be symmetric to other lines and points. Okay, so it can be symmetric to other things, but we're just going to focus on these three symmetries. Okay, so it might have symmetry, but if it doesn't have these symmetries, we're just going to say, you know, not these three or none of these, things like that, okay? So here are some formal tests, okay? When we do a formal test for a y-axis, we substitute a number and its opposite, okay? So if I substitute in 2, then I'm going to substitute in -2. When I do that, if they are the same y value, down here. Oh, I skipped. I said the informal. Sorry. Formal test for symmetry. Y-axis, replace x with negative x. The formal test, I mean, we're going to practice a little bit, but this goes with the algebraic way, how to do even and odd also. Replace x with negative x and produces an equivalent equation. Replace y and negative y and produces equivalent equation, same equation. With the origin, we replace x with negative x and y with negative y, and it produces the equivalent equation. Okay, so this is just by the equation. Okay, we're still using variables. But the informal test is when we're actually substituting in a number. So this, we're keeping variables. For the formal, for the informal, we're substituting a number. So back to where I was. If we were to substitute in 2, we would then substitute in -2. If it's the same value, we have a y or an x-axis, depending on what we were substituting in for. For the origin symmetry, what happens is when we substitute in, let's say, 2 and -2, you get opposite answers. Remember, opposite values are one's positive, one's negative of the same numeral. So -3 and 3. Okay. So the informal tests are not foolproof because it depends on what numbers you're using. If you use 0, 1, those could be really tricky numbers that might give you a false positive. So you need to be careful what numbers you're plugging in. Okay, so we're going to practice some of that now. And it really doesn't matter whether you do the formal or informal, guys, at the moment. I like doing the informal because it's the easiest one. So since I have a y equals, I'm going to plug in for x. So I'm going to say check on if x equals 2 and x equals -2. Now again, this doesn't say calculator or non-calculator, so I want to make sure that I'm able to do it in both situations. So 2 is something I can do in my head. 2 cubed is 8. 8 times 2 is 16. Minus 2, that gives me 14. Okay. Now if I plug in -2, -2 cubed is -8. -8 times 2 is -16. Minus a -2 gives me -14. As you can see, these values are opposite values, so this concludes that we are we have an origin symmetry. Okay, I'm going to draw a line so we know the difference in work. Okay, we can do this again. It's y equals, so we're just going to substitute in for x. I'm going to do, I'm thinking about doing 2, but I might not want to. I'm going to do maybe 3 in this case because I'm worried about that 2 right there. So I'm going to say x equals 3 and x equals -3. Okay. So if I plug in 3, 3 minus 2 equals 1. -3, well, the absolute value of -3 is 3 minus 2 is 1. So these are the same, and we were plugging in for x, so it is the y-axis symmetry. Okay. Now here we're plugging in for y, okay? So I'm plugging in for y, and I know I'm plugging in for y because that's where there's a major function in there, okay? So I'm going to plug in x equals 3 here. Not x, we're doing y, right? Y. See, this is why it's good for you guys to use a pencil. Y equals -3. Okay, so let's test this out. Absolute value of 3 is 3, so we get 3 equals x minus 2. I bring that over, we're adding, right? So that's 5 equals x. And then, let's see, absolute value of negative 3 is 3 equals x minus 2. So 5 equals x. These are the same. But remember, we plugged in for y, which means it's an x-axis symmetry. But we also have to remember that this is not a function. What this actually looks like, guys, is, remember, this tells me I'm going to the right. So 1, 2, and then it's the absolute value, but it's kind of on the x-axis there. So that's what that graph looks like. Okay, even and odd functions. In secondary 2, when we did even and odd functions, we just looked at the graph, okay? Because an even function had a y-axis symmetry and an odd function had an origin symmetry. But in secondary 3, I think we started to do it. If you took 1050, you already know how to do this. The idea is we're going to do it algebraically. And this is where we find that f of negative x equals f of x. For an even and for an odd, f of negative x equals negative x. Okay, so I am going to show you algebraically how to do this, but then we can use the same idea we used above by just plugging in numbers, okay? So I'm just gonna do the algebraic one with you first, and then I'm gonna show you how we can just plug in numbers like we did above. Okay, so if I were to test, and I'm going to do it actually on another sheet of paper here because I'm going to run out of room for the algebra. So I have f of x equals x cubed minus x. So I'm going to test f of negative x. That's just plugging in negative x for all my x's. And when I simplify that out, well, a negative 1 cubed is still a negative 1. And I'm plugging in a negative x here. A negative times a negative is a positive. So as you can see, f of x does not equal f of negative x. Okay? So it's not even. So let's try odd. Odd says that f of negative x would equal negative f of x. Okay, now we already did this, right? We did it right up here, so I don't have to do that one. So let me test negative f of x. That means that I would have negative this whole x cubed minus x. So I'm going to distribute out that negative. I get negative x cubed plus x. And what do you know? They do equal. So this works, which means it's an odd function. Now, I know I went through that super quick. It's because I want you to do it the easiest way possible. And the easiest way to do that is just to plug in numbers in its opposite like we did before for the symmetry. Okay, so I'm going to plug in 2 right here. So if I plug in f of 2, I get 8 minus 2, which is 6. Now remember, I didn't put 2 equal signs, okay? That's a false statement. So you need to make sure that you're writing appropriately. Whether you do an arrow here and an equals here, it's fine, but no 2 equal signs. And then let's try f of negative 2. If I do f of negative 2, well, that would be negative 8 plus 2, which is a negative 6. And because these are both opposite, it is an odd function, which is also in origin symmetry. It's nice that you can do one thing and figure out two. Okay, let's do it again. I'm still gonna use, I might not want to use 2 because of the 4 here, but let me see if 1 works well. Okay, so f of, and this is g, not f, g of 1 equals 1 minus 4, which is -3. G of -1 equals 1 minus 4, which is -3. Because they are the same, it is an even function. And of course, that would be a Y symmetry. The next one, let's do 1 again because I don't think it's going to be too confusing here. So H of 1 equals 1 plus 2 plus 2. That equals 5. H of -1 equals, well, that's 1, -2 plus 2. Oh, that equals 1. So the opposite, when we put in the opposite, we get 2 different numbers. That means it's neither. And there's no symmetry either. Okay? All right, points of intersections of 2 graphs, but without a calculator. So of course, this is systems. Okay, and there's multiple ways to do systems. So we are actually going to go quickly over them both. Not them both, there's actually 3 ways in this case. But right now, if you know how to solve systems, why don't you just stop the video and practice? I think this is all that's left. So if you want to stop here, go. But I'm going to show you a couple methods. So the first method I'm going to do is substitution. And I'm only going to substitute one into the other. So what I do is I rearrange one of them and substitute it in. Okay, so I am actually going to rearrange this first one to say y equals x minus 1. I did that very quickly, but really what I did here is I subtracted 1 here and added y here. Okay, so then what I'm going to do is take this second equation and substitute in for y. So I get x squared minus, now I'm going to substitute that x minus 1 in there instead of the y, equals 3. And now I'm going to solve. So I get x squared minus x plus 1 equals 3. Remember, before I factor, I have to set it equal to 0. So I'm going to move that 3 over. So that's -2 equals 0. Now I can factor. What 2 numbers multiply to give you -2, but add to give you -1? That would be -2 and 1. So I have that x equals 2 and x equals -1. Now I'm looking for points of intersections. These are just the x values. So what I'm going to have to do is plug the x values back into the equations to solve for y. It should not matter which one you plug it into. It should come out the same for both. So when I plug in 2, I get 1. When I plug in -1, I get -2. Okay, next one. I'm going to actually substitute again, but this time I'm going to rearrange both of them and set them equal to each other. So in this one, when I rearrange it, I get y equals x squared minus 3. So now what I'm going to do, because I rearranged both of them, is I'm going to set them equal to each other. I get x minus 1 equals x squared minus 3. Then I'm going to move everything to one side. I know we're used to moving it to the left side, but the truth is you want to move it to the same side as a positive x squared because then you don't have to manipulate with the negative. You can't factor with that negative. So I get 0 equals x squared minus x minus 2. And what do you guys know? These are the same. So I would factor, and of course, I'm ending up with the same intersection points. I did not continue the work on this problem here because it's the same thing as down here, okay? And one more. The other way how to solve for points of intersection without a calculator, sorry, my voice just went up. I sound like a chicken. Is elimination. If I could spell that, that's awesome. Elimination. Now, elimination sometimes gets a little bit tricky, especially when you're dealing with a bunch of x squareds and x's and x cubes and all that other stuff, okay? So what we're gonna do first is put x minus y equals 1. Then what I'm gonna do is when I put the second equation under it, I'm gonna make sure I line up things, okay? So I get x squared minus y equals 3. Okay. Now, because they are the same, I need to subtract it. Or I can multiply by something and make it so I add, because adding is so much easier, right? So if I look, I have to just multiply, I can multiply the top one by a negative. You guys see how that worked? I multiply everything on top by -1. And now because these are the opposite, I can add them. And it makes it a little bit easier with adding, so we're not confusing on our negatives. So 0 plus x squared is x squared. Negative x plus 0 is negative x. Y plus negative y is 0, so I don't have to put anything down. And -1 plus 3 is 2. Again, I can't factor yet until it's equal to 0, so let me move that 2 over. X squared minus x minus 2 equals 0. And what do you know? We're in our same equation that we can factor, and we end up getting 2, 1, and -1, -2. When your problem asks you to do this algebraically, you can choose whichever one you want. Just remember that you need to show your work and your answer needs to be in those coordinate pairs. All right, enjoy.